The next topic now is to look at a little bit more detail around what OSM has actually delivered with Release 3, or rather a preview of it, which is happening hopefully later this week. Now, my name is Adrian Hoban. It's a pleasure to serve as the chair for OSM, and it really is a pleasure because I'm getting to work with some of the most creative and innovative people in the business. So it's my pleasure to represent the work that the whole community is delivering. Okay, I want to start again with the architectural principles, and that's because these really are important to us. They're not just bullets that we put up on some material. We've heard from our leadership group and from the end-user advisory group today that things that we represent here as part of the architectural direction are important to them, and they are important to us too. So if you look at topics like modularity and layering, they're really important that we get those right and that we stay focused on maintaining the modularity and the layering that we started with OSM. It's all too easy to allow a little creep into your architecture when you get more and more functionality added over subsequent releases. The abstraction has to be right too. There's not much point having multiple modules and multiple layers if the abstraction that's been offered between them doesn't further the mission of making it simpler to consume further up the stack. And then last but certainly not least is the simplicity topic. Now, I actually was commenting to the organisers of Layer 123 event today, Mark Lum and Marion Fisher, about how smooth this event is running. And one of the comments back to me is, yes, but there's a lot of this activity underwater that you can't see. And that's what helps an event like this run so smoothly. And the analogy of that in the context of our principles in OSM, the simplicity that we want to deliver to the users requires us to do a lot of that complexity under the hood and to make sure that we're hiding that in a very effective way. And that's really hard to stay on top of, but it's something the community is really passionate about maintaining that. Because if this isn't simple to consume when we're done, people won't consume it. NFV and some of bringing some of the technologies from cloud to the networks, this is an innately complex topic. So it's really important that we're focused on making this thing simple to consume. The picture here on the right is familiar to most of you folks, I guess, coming back from the SDN NFV MANO specification. And it's focusing in on just the management and orchestration pieces of that. And I wanted to show the overlay then of where OSM fits. But actually, before I maybe jump into the different colored boxes here, probably the most important and out of scale box in this picture is the OSS BSS box. Why? Because OSM is not trying to be an OSS BSS. It's there to make the job of consuming the value add of NFV really straightforward. It's there to make sure that the investment that operators already have in their OSS BSS environments can be maintained and leveraged. And we want to make sure that what we're doing here furthers that, simplifies it, and basically allows people to move forward with consuming the value of NFV. There were two, I guess, macro design themes around OSM and what we're trying to achieve. There's the runtime scope, and runtime, as you might expect, is looking at an end-to-end service delivery. So by definition, it goes slightly beyond the original definition of that MANO reference architecture. It's moving up into that service space, and it is intending to focus on the end-to-end aspect of delivering a service. It's there to implement the functional ideals that were set out in the specifications through MANO. You've heard many, many times already today about the importance of interoperating with all of the components that are not MANO. So the SDN controller, the VIM, with Release 3, an experimental solution around the monitoring tools. There's a lot of investment around the orchestration componentry. We want to maximize the value of that and pull that through. The ability to support a generic VNFM integrated in OSM. And part of that, by the way, is because a generic VNFM integrated in the way we have with OSM is a really great way of getting you the kind of control you need on your resource allocations through our architecture, driving that through the resource orchestration side, but then also providing all of the key events and configuration mechanisms that you want that a generic VNFM is designed to deliver, but giving you a path to go and deliver that with the least of complexity. You'll note here too, right, this isn't all about virtualization. There is an investment in physical infrastructure. There's a P&F box on this for a very good reason. You do need to integrate with physical infrastructure, and that is typically as a part of brownfield deployments. So OSM is very much targeting our runtime deployment to support, yes, greenfield in some cases, but mostly it's about a brownfield. The design time scope. Now this is really about supporting the different type of actors in the operator environment. So the folks that need to go and design a network service. Even before you get to the operator environment, the folks that are creating a VNF package and want to say how should this package should be onboarded in an OSM context. Our design time tooling is very specifically focused on helping the VNF vendor community package something up in a way that's super easy to consume. It's also about making sure that they're doing it in a way that keeps them abstracted from all the layers underneath to simplify their role, allow the orchestration environment to do the things that it's really good at. There's a GUI then wrapping up all of this. And whether you're a fan of a CLI model or you'd like to go to GUI model, there are multiple ways you can engage with OSM, particularly through that interface. And we're finding lots of people who may start with a GUI, get all the structure in place, and then start diving into the different aspects of the model to help refine what they want to deliver on. So I want to dive into a little bit more detail then. And I want to start off with DevOps, which for us it's a new module as part of Release 3. And it may seem like an odd one to start with, but I'm starting with this because it sets the tone for what we want to do with OSM. It sets the tone for what we want contributors to OSM to go and deliver into OSM and what's expected of them. So we've mentioned earlier today around the one-click installer. That's really important for us. It's important that, like I say, this is easy to consume. It's important that some of that complexity of deploying a distributed system are hidden from users. The other part of our DevOps piece, and that ties into the whole workflow, and I'll talk about it more later, but the fact that we integrate all of these steps and make it really clear to the users in the OSM community that it's integrating with this model is what's expected, that helps us keep the quality high, helps us manage technical debt. Looking at the UI then, the user interface, start from the top. Again, like I mentioned, we've got the design portion of that focused on the VNF packaging pieces. But we've also got the VNF and Network Service Catalog Manager. So for the composer, so for the folks in the operator environment that need to go and create it ahead of time, create what kind of services they want OSM to deliver, they have tooling to help them do that. Before we move on, the runtime side then, looking at the kind of practical things that you really need to have in your orchestrator. These aren't very glittery type of features, but they're necessary, and they're necessary that they work really well and that they're functional enough to be deployed. So if you look at things like account management, how is that enabled through our UI environment to make sure that that single pane of glass into the system gives you the right level of visibility? Launchpad is the key user interface tool for graphically managing how the system behaves, for things like deploying network services, upgrading them, installing or instantiating new VNFs. And we also added in the last release the OSM client. Now the OSM client, if any of you folks are familiar with some of the way that, let's say, the OpenStack CLI works, very similar type of model. So the fact that you can, with a really simple command, do things like instantiate a network service, that really adds to the type of or ease of use that we're going after. The service orchestrator represents what I would say is really the core heart of the orchestration within the OSM environment. At the top, obviously we're showing layering here, so we've got API endpoints and we've got the management endpoints to go and access the SO. The service orchestration engine itself is effectively the puppeteer. It's figuring out when it sends a request to the resource orchestration side, when it gets that back with the resource that has been provisioned, and it's managing this workflow so that when you're driving let's say the day 1 or day 2 config time activities through into VC and VCA, that's a coordinated function. Heading towards some of the properties we want to talk around in resiliency, we've got the configuration data store. Now that config data store allows us to store in a distributed fashion a lot of the running state within the SFs or the SO. So when you look at things like a running network service, you get to see, or you get to store that outside of that particular running environment to ease the idea of resuming that capability should anything happen and you had to restart your environment. We've got the network service composition engine, and that's focusing on making sure that the actual service that we're trying to deploy is compliant with the definition that went into the service and compliant with the models that are running through the system. OSM is model driven from top to bottom, so having this ability to do some pre-validation of the service you're deploying is really helpful. And then there's the resource orchestration engine, which gets us that conduit into the resource orchestrator. Again there, one of the key tenets of the resource orchestrator is that we're managing all of the multis, multi-VM, multiple instances of it, geo-dispersed VIMs. We've also got the SDN plugins. So while you can access SDN through a lot of the Vim environments, that's by going through their various network interfaces for the VIMs, we also have the provision to go direct from the resource orchestrator to the SDN controllers, whichever one you choose. Right now, we've got 3. We've got Open Daylight, ONOS, and Floodlight. But one of the things that adding this or making sure that we're driving through this plugin framework does is it puts a lot of pressure on us when we're going through our data model to make sure that the things we put in that data model are sufficiently abstracted from the realities of these different implementation environments. That allows us to make sure that the VNF vendor community, when they come to us with their application, that they can model it in a way that it too is not tied to that low-lying implementation. When we do that, MANO is serving its purpose. It's removing that complexity from the difficult job of deploying and running network services. On the think of that left-hand side of our architecture, the N2VC and the VCA. So these components are all about how we manage the configuration space. How do we get actions and events both into and out of either VNFs, VNFMs in the specific case, or element management systems. And it's about, particularly, this is where the service aspect of running OSM really kicks in, because you're primarily looking at day 1, day 2 operations. And then new for release 3 is the monitoring module. Now, it is still experimental, but at the heart of the monitoring module is continuing to take the design principles from N2VC, VCA, and DSO, and it's saying, we want to have a plug-in model where we want to leverage the capabilities that exist outside of OSM in the most effective way possible. So even just to start with, we have some capabilities around OpenStack A and Noki integrated. We've got VMware vRealize Ops integrated to support the cloud models that we already support on the deployment side. Amazon CloudWatch has been integrated. So still experimental. We still have a long way to go before we'd be prepared to take that tag off it, but it's heading down the right direction. And we're heading down that direction because this has to be a platform for service delivery, and service delivery requires service assurance, which requires monitoring. So we'll continue down this path. Watch this space for release 4. We think there's a lot of good developments to come in that area. And last but not least is the thing that actually pulls this entire system together, and that's our data model. And the data model is aligned with SDN NFV. In this case, it's aligned with SDN NFV information model. Here we've got a data model implementation. All of the work we've done through places like PlugTest and elsewhere is showing that the data model that we've developed works, and works in a way that spans these multiple environments, multiple SDN controllers, multiple VIMs, and it does so consistently and reliably. So with that, I want to focus a little bit on some of the functional additions that have happened with Release 3. Now, I mentioned DevOps to start with. Here I'm showing the 4 different phases of DevOps. So our first phase, and what I want to say, thanks to the Etsy hosts, because they've provided us with all of the best tooling. So really the impetus was on OSM's technical community to go and leverage that. And actually, before I dive into this detail too, there's another part of DevOps that I'm really pleased with from OSM. If any of you guys remember back when we started OSM, we said, look, we've got all this seed code, and these different communities came together to create what formed OSM. And we said right at the start of that, one of the things we want to do as a community is facilitate new members of the community taking on leadership type of positions. DevOps is an example of that. We've got a wonderful guy, Michael Marchetti from Sandvine, who came in well after all of that seed code had been delivered, and he stepped up and he's totally revolutionized, or modernized rather, the environment we have for DevOps. Now the MDG lead for it. So an example that OSM, while it's a lot about technology and delivering things that operator needs, to thrive as a community and keep developer interest, we have to show that there's a progression path and that there's opportunity for people to come in and participate and take on leadership positions. What Mike did with DevOps is wonderful, because what we've got here is the 4 stages. We've got the first stage, which addresses some of the ways Jenkins works. We wanted to be able to kick off multiple stage 2 testing in parallel. So a lot of that stage 1 is around managing the Jenkins environment. Stage 2 then is around integrating all of the unit testing capability per MDG. So when there's a commit, the code is unit tested and we get a verified result. So the empowered module development leads know ahead of time that this is a code that's now worthy of review, that meets the requirements. But we're also doing things like running fossology, running licensing scans, because this is code that needs to go into production. We need to protect the code base. We need to protect people's IP and make sure we're all being compliant with the licenses that people signed up to, all Apache 2, by the way. We've introduced a JFrog Artifactory as well here, and that's to manage the outputs of DevOps. So the artifacts that are created, so that once we have a successful stage 2 build and we know the unit test pass, we're leveraging that build artifact to get stored, and later on we come into the stage 3 part, where we start into the installation of OSM and making sure our environment continues to be both robust and stable, that we're leveraging all of those build components and we're reusing them. That then is consumed as part of our smoke testing phase. Now, with smoke testing, this is really making sure that all of the basic functionality of OSM continues to work. Things like network service instantiation and creation and deletion and updates. Moving on then past the stage 3, we get into stage 4. And this is where, and we'll talk about some more later too, the multi-Vim environment that we've got set up with Etsy's, with their Hive, their hub for interoperability and validation at Etsy. So in this environment, which has been really useful for us in finding, before customers find various challenges with running a distributed system. So we've got these VIMs all over the world that we can go and access and deploy it with an orchestrator centrally located. And what this allows us to do is true end-to-end testing at the service delivery level. Now, moving on then into security. Really important topic that we get and stay on top of security. And there's going to be some demos in the later on session this afternoon. But what I want to introduce here is the concept around the multi-project idea and role-based access control. These are both two pretty tightly coupled concepts. But really at the heart of why we wanted this capability in OSM is we said, well, if you look to, let's say, something like OpenStack Progress, and that you have a tenant which is now a project type of model, you have a choice when you're looking at these systems. You say, do you allow that type of Vim construct to get exposed all the way up the stack, or do you insert layers of abstraction that allows you to have an operator environment that reflects the operational policies and structure of the end user community, and then translate between that and the operational policies and tenants that you want to set up at the Vim environment, which might be the preview of the NFVI administrator. So the multi-project and the role-based access control are the key technologies that we've added for release 3 that add that. Where multi-project then gives you that ability to really combine or consider the consumption of like the VNF and network service and various aspects of the resource, be it an instance of Vim, into that project level view. And then where role-based access control can further refine per user their permissions within the context of those resources. So there's going to be a more comprehensive demo on that later on. Next up is on service assurance. And while I believe very strongly that my points earlier on monitoring certainly hold in service assurance, one aspect of service assurance that we started with release 3 on, and which we did as an experimental feature for release 2, was the idea of network service scaling. Now, at the network service scaling, what we're talking about is the idea of scaling VNFs. So whether a VNF itself contains multiple VDUs, or VNF containers, or your preferred languages, at this level we're going to scale the entirety of a network service. And for that, we've pulled through the concept from the IFA 11 on the scaling groups. So when you identify that you've got, let's say, 2 particular VNFs that are part of a network service, and to scale these, you need to scale the 2 as a joint unit. The way that we've implemented that in the data model and followed that path through the system, through the SO and the RO, and then down on the VCA side to make sure that we're configuring it correctly, is to leverage that scaling group principle. Now, this allows you to scale both in and out the performance of that network service. It's quite important for us that we actually started with this. We said it was an experimental for release 2. We're more comfortable now that we've done quite an extensive piece of testing on this, that it's robust enough for you guys to start looking at consuming it. One of the challenges when you look at service delivery is to make sure that the environment that you're expecting, particularly from the virtualization perspective, looking at it from a VM side, is actually what you got. So if you consider a fairly rudimentary case of, let's say, a firewall, and you've got a WAN side to your firewall and a LAN side, you really want to make sure you don't mix those up as part of your deployment model. So one of the things that we've enabled with Release 3 are 2 different mechanisms for ensuring that you get consistent port ordering. Now, this port ordering, it's not at the NFVI layer, to be clear. This is port ordering that the resource orchestration side of our system is helping to ensure gets allocated from the VM perspective, so north of the hypervisor. So in effect, it amounts to virtual PCI mapping. Now, we have 2 different methods of enabling that. You've got the method where you can actually specify right down to the VPCI addresses if you need to, and there are some use cases where you might want to do that. But there's the other method which allows for less complex, less involved data model definition of your work. And that it requires to make sure that your VNF itself is able to interpret things like device role tags. So one of the concepts that was introduced in an earlier OpenStack release. So with the device role tagging and us leveraging that through the stack and abstracting it into the model so that we can have the right tags within the model, that allows us to very precisely make sure that when we define that an interface needs to represent a particular ordering in the system for the VNF, that it actually gets that. And it gets that consistently. So if an interface went down and comes back up, it's back up in the same order. As you can see, service assurance is a hot topic for us. We've got lots of topics on it. When you look at the affinity and anti-affinity settings, again, this is really about OSM working to enable deployment models that work for the VNF vendor community. If you think of even the quite common active standby type model, what we've done with the affinity, anti-affinity is now leverage the capabilities coming through from the Vim environment to make sure that when we are deploying, these things are distributed in a way that the NFVI administrator has permitted. And remember, this is part of the layering too, that there is an element of understanding that the NFVI admin within the operator environment is responsible for saying, what are the particular zones, and we can work with that as a part of the modeling framework. You look at service assurance from the perspective of keeping that service up and running. One of the things that we found out from the geo-distributed testing that we've been doing is the idea of concurrent access to multiple, both instances of the same Vim and concurrent access to different types of Vims. So we've made some changes on that side to make sure we can go do that. That adds a considerable level of robustness to the system, that you're not getting stalls or slowdowns as part of your service delivery workflow. And then the monitoring solution, well, part of the solution right now with the plugin support that we've got. One of the, I guess, key tenets of the monitoring solution that we're particularly pleased with from an architecture perspective is the concept around correlation. Now, in fact, this is what we think is probably even more powerful to us in an OSM context than the plugin model, because if you think about what really are the challenges of service assurance in a virtualized or cloud-like context, and one of it is to be able to correlate what's happening at the NFVI environment, what's happening at that lower layer that, frankly, the VNF has and should not have exposure to. And quite frankly also, the SO, that the service orchestration layer, shouldn't really have direct knowledge of. So the key concepts around correlation and what's integrated into the core of OSM monitoring solution is that we work with a plugin model that allows for pre-correlation of NFVI events into VDU level events. Now, whether your VDU is a VM or some other construct down the time, that's fine. But what you get back is an event that's associated with the thing that you're actually doing some service management on or resource management on. You don't need to know about the hundreds or thousands of things that happen at the NFVI environment, at the SO layer. The system does need to know, and you do need to be able to double-click and figure out if something went wrong, what happened, and how you go fix that. But in order to move in the direction that the end-user advisory group has set up for us, which is very much we want to head towards the idea of a policy-driven and an automated environment that can take the corrective action under policy governance, you need to have that correlation, and you need to be able to leverage all of the value add that's happening in the monitoring space. So moving on to resiliency, and this is where we're making steady changes. We're certainly not finished with this yet, but if you look at, let's say, resiliency to per component failures, some of the things that we're working on are to make sure that in every case where there's some state managed within a component, that's stored in an external database where we have a resiliency model set up. We look to make sure that if a state has to be passed around the system, that the way we manage those event bus messages is consistent, so that if something gets passed in and for some reason a failure happens, we're not losing that event. Another one on the resiliency is the idea around both remote and multiple VCA instances. So part of this is looking at, well, you know what, if, let's say in release 2, we had this idea that a VNF exposing a management interface, at that point we had expected, let's say, either a floating IP or direct assignment access. So you could access it from outside the data center. But that might not be the resiliency model you want. And in fact, you may not have that type of access in deployment. So what we went and added for release 3 is the idea that some of the VCA components could be deployed at those remote locations, removing the need for that external accessibility from the VNF side and harmonizing that through just one interface onto the VCA piece, which we know we can secure. Combine that, plus then the concept of having multiple VCAs allowed us to have a far more resilient deployment model that had less single points of failure. Moving on to usability, and we talk a lot about usability. One of the artifacts of the original OSM releases was that we had multiple components that we combined. We're working on a very methodical process to make the OSM environment be perceived as a very coordinated unit. And part of that is to make sure that the interface into OSM is that single pane of glass, that consistent interface. So we're continuing to work on API consolidation. We're continuing to work the interfaces internal to OSM. These are generally not exposed to the user. And we're continuing to make sure that the right level of info is being passed across those interfaces so we can get to that single API on the top. We've made really good steps forward for release 3. There's a few more areas we want to tidy up in release 4. But this type of activity represents the balance that we're taking in the technical community in OSM to address the needs from the end-user advisory community while also addressing the needs to bring the architecture forward to make sure that it's something that we can continue to develop and advance without consuming technical debt. There's another usability-related topic we've added is more feedback when you're going through the installation process. So very frustrating if you're to sit at a desk and you've tried to install something and nothing's happening. Lots of things are happening, but you can't tell. So one of the things we wanted to work on is that there's far more feedback coming in near real time around what's actually happening in your environment. So that gives you nearly a heads up if you need to go and figure out if you need to take corrective action on something. And we continue to update the CLI to make sure that that stays in sync with all of the data model progressions and the interface progressions that we're making in the community. Now, I want to touch on interop here. So in this context, the first piece really is looking at OpenStack v3 APIs. So this is one of the cases where you say, okay, there's a lot of work around the standards that are applicable in this space, but there's an awful lot of work happening in the components that we need to interface with. So if you look at OpenStack and how that's progressed as one example, and they moved from the v2 API to v3 API stream. In this context, it mostly impacts the authorization primitives like Keystone. And you look at the v3 and that's added all this micro-versioning support. and the fact that that open source community made a decision, which it's completely entitled to do, to deprecate the V2 API. This is the type of challenge that the orchestration environment has to do. It has to stay on top of what's happening in the plugins, the environments that our plugins need to interface with, and stay on top of those progressions, because they're innovative communities, they're making changes for the betterment of the consumption at that layer. OSM, as an orchestrator sitting on top, needs to respond to that and do the same. Our remote labs, from an interoperability perspective, is one of the best pieces of functionality we've got in our CI/CD environment. It really is, because consider the complexity of any VNF vendor developing the app in their own environment, maybe with limited access to a Vim environment, or certainly it'd be a shared resource. And we've got this environment that you can access with the stage 4 testing, where you don't have one environment, but you've got, I think it's up to 4 or 5 different Vim environments, different versions of it, different types of Vims, geo-distributed with different SDN controllers. What a fundamentally brilliant starting point to go and do interop testing on. And we've got that integrated with our environment. That allows us to make sure when we put a release out there that we can stand over and say, yeah, this is working really well on a really wide set of things we've interoperate with. On that interop, and it was mentioned earlier, for me, this is another great thing about the OSM community. One of the things that we have to do at the technical steering committee level is to look at prioritizing the functionality per release. A lot of inputs coming in from the end user advisories. Those guys are really creative. They come up with a lot of cool stuff for us to go do. Generally isn't enough time, so we've got a nice prioritization challenge. And we'll have another one again in a couple of weeks' time for release 4. But one of the things that's great about OSM is that just because we didn't prioritize it doesn't mean it can't happen. And this is a great example where some really innovative folks from the research community, in this case with Sonata, they developed this functionality that we said, well, this is a really great fit into the environment that we want to cultivate in OSM. And you know what? This is really easy to integrate. They've been paying attention to what we're doing. They've looked at what it would take to integrate it, and they did all the pre-work for us. It became a super easy decision to say, yes, let's adopt this, let's consume it, and for release 4, we're going to build on it and integrate it into our stage 3 pipeline. But this ability then, what it adds to the user community is that this resource that tends to be a difficult thing to get your hands on, and particularly given a testing environment where you might be subject to some hysteresis type effects in the Vim, that you now have access to an emulation platform that allows you to do the majority of your stage 3 level testing. That'll be integrated with release 4, but the concept here is that we can get to that point where now you've got a much better platform for doing all that work. So when you land your VNF into an operator environment, you've done enough of work to know that that's going to be a smooth process. And then last but certainly not least is the way we want to coordinate with the industry. Like I said, the data model is a really fundamental aspect of OSM. It's what glues all of the components together. It permeates our interfaces. But it's something that we also believe we have a lot of experience with actual deployments, and particularly with all of the interop we're doing. And we're actively working to feed that back into the SDN NFV, particularly the interfaces and architecture group. And they've been incredibly receptive of the feedback. We've got a lot of work to do to go and make some progress. A lot of the feedback, by the way, is focused on things like ambiguities, which may be just, hey, we need to tighten up little parts of the information model so that we can all make sure that the data model representation of those are consistent, and that promotes interoperability across communities. So we're going to continue to do that. We have feedback with the community. We'll continue to work it. We're going to look to land hopefully quite a bit of that in the maintenance releases, subject to the interface and architecture working group exceptions. But this is also a model I think could work for other communities. So for other communities that are working, be they proprietary or open source, please consider engaging, look at our feedback, submit your own, and let's work together to make sure that the information model that we're all keying off of is consistent and precise enough that allows us to deploy the things we need. So with that then, where we're going with release 4. So too early to say definitively, so this is the kind of things we might do. That's very much not a commitment yet. We have to go through the process of consolidating all of the feedback from our end-user advisory group, and then we've got to work the process to make sure that we can actually deliver it in our 6-month release cadence. We're quite proud of sticking to that. But what I want to say here is that I believe the themes that we've selected several releases ago were the right themes, and we continue to progress on these. But each release, we're looking at different functionality within the themes. So on that service assurance topic, the ability to modify a running service, that's something every operator is going to have to do. We don't support it yet, but we will, and I hope it'll come in release 4. You look across usability, and you look at, let's say, doing even more on the metrics correlation, particularly from the application side of things. Right now, we've done a lot of focus on the NFVI side, correlating that to VDUs. We've got more work to do over on the app side. We definitely want to push ahead with that. We have to do more on resiliency. When people deploy this, we expect it'll be running for a long, long time. It's important that what we produce is resilient and that continuous upgrade processes are adoptable. And we'll continue to push on our DevOps and our CI/CD. That's the way we'll manage the capability within OSM and keep our code functional. And then just a call out to 2 upcoming events. So release 4 plenary, it's coming up at the end of the month. So folks that are thinking of joining OSM, there'll be a great opportunity to get in and contribute to release 4. As you can see, it doesn't take a long runway to get involved in OSM and to make an actual difference in what we're delivering. So consider joining that. And also we've got the VNF plug fest, or sorry, the SDN NFV plug test coming up. And at that, we're going to run an OSM VNF onboarding hackathon. So if folks want to join us at that event and do some pre-work perhaps, we'd very much like to support that. Come with us. You'll get to benefit from all of the expertise of the leading figures in the OSM community to help you onboard your environment. Okay. So that's it. Thank you, everyone, and thank you for the End User Advisory Group and the chair for giving the intro to OSM. And in the session after the break, we're going to do more of a tutorial focus. We're going to get to see some demos that have been delivered with OSM, how the graphical user interface works, and more info around the configuration side of the architecture. So, thank you.